Hi, this lesson is all about a property that we haven't really talked about so far. It's the competence of rock. Now, we're starting topic G2 with this because really it informs uh, how rocks respond to stress. Because we can see different types of rock responding in different ways to the same stress. For this lesson, there is a handout which is a photograph of the folds that you can sort of see in the background of this image. Okay then. Okay, let's start with some of the basics. We're going to be talking here about beds. Now we've talked about these before. It's a layer of rock. We have bedding planes dividing up these different types of rock, and one of these beds represents a single unbroken period of deposition. The thickness can vary tremendously, but we need to look at this idea of a bed because it's and the bedding planes especially because it's that's going to define how a rock is actually responding to this stress. So here's an example. So we've got our bed there, our uniform or generally uniform layer of rock with these bedding planes top and bottom. These are fairly thin ones. They could be thinner again, down to a centimetre or so, or they could be many metres thick. Okay, and it's these bedding planes that really define what we're looking at here. Okay, a bedding plane is really some type of change within the deposition. Okay, the rate or the type or even the rock type will change and define a new bed. Now, if we think about what we mean by competent beds, this is a bed that when it's put under stress and folds, it doesn't change its thickness. So the rock may bend, but the thickness of the bed, so the distance between its bedding planes, doesn't really change. Another way of putting this would be it's a strong rock. It doesn't flow. Okay, but we don't talk about strong and weak rocks. In geology, we talk about their competence. So a competent bed is one that, when it bends, retains its original thickness. Which means, obviously, then, an incompetent bed is one that does deform. It does change its thickness. It does perhaps flow during folding. These tend to be these are the weaker rocks, clay especially, mudstone, shale. These will, if you like, get squeezed and change their thickness during folding. This is the photograph you have in your handout. What we have here are sandstone and shale beds near Bude. And you can see that these rocks have been folded. We could start even by drawing in the axis of this fold. Where would the axis of this fold be? We may even be able to start to describe some features of this fold. We don't need to worry in this case about whether it's a anticline or syncline. If we look at the rock types we have here, though, we've got sandstone and shale. The sandstone is the lighter coloured, or the lighter coloured beds. The shale is the darker coloured beds. What could you annotate on this photograph? What can you identify about these rocks and their deformation? See if you can put some detail on your photograph. Perhaps press pause now and have a go at that. Okay, this is some of the things that I've seen on here. We've got the sandstone here is competent. If you look at the thickness of the sandstone beds as they've been folded, it stays pretty much the same. If you look at the shale though, particularly the one I've labelled up there, we've actually got a big change in the thickness, particularly around the hinge of the fold. So the shale here, when it's been folded, has flowed because it's incompetent. The sandstone, as it's been folded, is actually cracked. We're getting tension cracks around the top edge of the fold there because it can't deform any other way. To see how much thicker, can we work out the ratio of the thickness of the shale from its thinnest point to its thickest point? I've marked in some some arrows there to measure. What does that tell us? Could we do the same for the sandstone? Think as well about the role of this actually within the fold. Do these incompetent beds allow the more competent beds to fold like this? Does it sort of help everything sort itself out? Let's have a look at one or two others. What do you reckon to this? This is in a mudstone. Do we think these are competent or incompetent? How do these compare with the previous example we've just been looking at? How about these? This is on a much smaller scale. You can see there's a small lens cap, about 50 millimeters across in the middle on the left there. What can we see going on with these beds? It's a feature we actually call tigmatic folding with a silent P. What does this tell us about the rocks? Okay. So we've seen that the competence, this resistance of a rock to change in shape as a result of stress, is an important feature in looking at folding and how these rocks respond. It's something that when we look through the rest of this topic, we need to bear in mind. We're not going to be talking about strong and weak rocks. We need to be talking about competent and incompetent rocks. There are no numbers for this, by the way. These are descriptive terms. Okay, that's how we're going to apply them. But it's something we need to bear in mind when we start looking at all the different ways that rocks can deform. But that's for another lesson. I'll see you then.